Hi guys, good morning, good afternoon, good evening, wherever you are in the world. Welcome back to my YouTube channel. Today we will be talking about chi-square. What is it? So, chi-square is a statistical analysis to test independence between categorical variables. With categorical variables, we are looking for the frequency of the occurrence of a certain variable. We are not looking for average or mean. What else does this chi-square do? It makes use of the contingency table to summarize the relationship between categorical variables. It contains the frequency of the observation to their corresponding row and column categories. It means that if you have two variables, you will either have to put it on the header or in the index. Chi-square is designated by this Greek letter chi with exponent 2. How do we do the hypothesis testing in chi-square? The null hypothesis is stated as there is no relationship between the variables, while the alternative hypothesis stated there is a significant relationship between the variables. Then we will compare the result of the p-value with our alpha level. For this video, our alpha will be 0.05. Other research can have a different alpha value, 0.1 for more conservative or 0.01 for more aggressive value. But for our video, we will stick to 0.05. If the p-value is less than or equal to alpha, we will reject the null hypothesis. We can conclude that the variables are dependent. It means that if one of the category of the variable appears, there will also appear a category in the other variable. If your p-value is bigger than alpha, then we will not reject our null hypothesis. We can conclude that the variables are independent. It means that one variable has nothing to do with the other variable. Chi-square is only applicable if the sample size is 20 or more, or if one of the cell is 5 or more. If your sample size is less than 20, it means that it's too small. When that happens, you need to use the Fisher exact test instead of chi-square. You will also need to use your Fisher exact test if one of the cell is less than 5. Over here, we are comparing two variables, the status of health and the prescription of medicine. Of those given medicine, 8 people have healed. 2 are still sick. The people given medicine is 10. There are no person that was not given medicine that have healed. And there are still 5 people who are still sick. You can see 5 people were not given medicine. If one of the cell in the 2x2 table is less than 5, how many cells do we have that is less than 5? 1, 2, so we will use the Fisher exact test. If the sample is less than 20, we can see that the total is only 15. As a reminder, this is just the meaning of 0 and 1 category. With the variable status, 0 means single, 1 means married. Aspirin status, 0 means no aspirin was given or prescribed, 1 means there is. Race, 0 means white, 1 means non-white. Gender, 0 means male, 1 means female. Insurance, 0 means no insurance, 1 means there is an insurance. With literacy, 0 means non-literate, 1 means literate. With education level, we have 4 categories. 0 means no formal education, 1 elementary education, 2 high school, 3 bachelor, 4 masters or PhD. Until now, I still don't know the income brackets, the meaning of 0 to 4 categories. But just like what we did with the student t-test and analysis of variance, we will retain the use of these numbers. Okay, now we are ready to explore our scientific inquiry and do hypothesis testing. Let us just open our diabetes dataset. What we will just do is open this box plot. The first list of variable is the one you will put in the header of the table. Then the subgroups will be in the index part. Let us check the civil status. We will compare it with the aspirin status. This looks like the 2x2 table. 0 single, the one on the top, 1 is married. 0 means no aspirin here on the left side, with aspirin also on the left side. Let us make a scientific inquiry. Is there a relationship between civil status and initial aspirin status? Our null hypothesis will be there is no relationship between civil status and initial aspirin status. Our alternative hypothesis will be there is a relationship between civil status and initial aspirin status. Is it more possible for you to drink aspirin if you are single rather than if you are married? For our 2x2 table, we will just get the value here in orange 3. When you hover the mouse here in the cell, you will see 44. And then, when you hover here, it is 45. We will just have to type it here. We will do the same with married. The top one is 51 and below is 40. The p-value that we got is 0.46, which means it is bigger than our alpha of 0.05. We will type the decision here as do not reject the null hypothesis. Our conclusion will be there is no relationship between civil status and initial aspirin status. They occur independently. Then we just need to copy paste the screenshot of the orange 3 output. It is kinda weird that it is called box plot. It doesn't look like a box plot. Remember that the version of orange 3 I am using right now is 3.31. So it means that the box plot of categorical variables, they would look like a 2x2 table. But when you choose a continuous variable, it will return to a regular box plot like what we have seen in the student t-test and analysis of variance. This is our first chi-square test. We will just have to fast forward the process. The categorical variables below and those at the top, we will compare them and then we will discuss the results, the decision making and conclusion. So after our speed up process, we will individually compare our categorical variables. We will now discuss each of them. This is our first one. We are looking at civil status and initial aspirin status. We got the p-value of 0.46, which is bigger than the alpha. So we will not reject the null hypothesis. There is no relationship between civil status and initial aspirin status. They occur independently of each other. Next, we look at civil status and 6-month aspirin status. As you can see here, we have a 2x3 table. We have here at the top single and married. And then here, no aspirin, with aspirin, and missing. Be very careful if this happened. Orange 3 has included missing value as another category of the variable. Supposedly, it should be 0 and 1 only. This resulted to a statistically significant result of our p-value of 0.000, which is smaller than our alpha of 0.05. But we cannot really make any consideration of its significance because of this unwanted missing category. Next, we look at the relationship between civil status and 12-month aspirin status. It happened again in our Orange 3 software. The missing becomes another category. In terms of practicality, we will not consider this significant, but for the sake of discussion, we will consider this as significant. Our p-value is 0.000, which is smaller than our alpha of 0.05. We will reject the null hypothesis. Next, between civil status and race. Our null hypothesis states there is no relationship, while our alternative hypothesis states there is. The p-value that we got is 0.37, which is bigger than the alpha of 0.05. we will not reject our null hypothesis. The variables civil status and race occur independently of each other. Next, civil status and gender. The p-value that we got is 0.563, which is bigger than the alpha. We will not reject our null hypothesis. The variables civil status and gender occur independently. Next, civil status and education level. So 0 denotes no education, 1 elementary, 2 high school, 3 bachelor, 4 master or PhD. The most numerous is 2 high school. The p-value that we got is 0.123. This is bigger than the alpha of 0.05. We will not reject our null hypothesis. Civil status and education level occur independently of each other. How about civil status and income? The most numerous is the one in 0 group. The p-value that we got is 0.84, which is bigger than our alpha. We will not reject our null hypothesis. Civil status and income status occur independently of each other. How about civil status and insurance status? 0 is no insurance. 1 is with insurance. The most numerous belongs to those without insurance. The p-value that we got is 0.843, which is bigger than the alpha. The civil status and insurance status occurs independently of each other. Next, civil status and literacy. 0 denotes non-literate, 1 means literate. The p-value that we got is 0.267, which is bigger than the alpha. We will not reject our null hypothesis. Civil status and literacy occur independently of each other. Next, relationship between race and initial aspirin status. The p-value that we got is 0.958, which is bigger than the alpha. We will not reject the null hypothesis. Race and initial aspirin status occur independently of each other. This is the same case as earlier, where there is a new category for the missing values. The p-value that we got is 0.835. We will not reject the null hypothesis. They occur independently of each other. Same thing here between race and 12-month aspirin status. Between race and gender, the p-value that we got is 0.42, which is bigger than alpha. We will not reject the null hypothesis. Race and gender occur independently of each other. Next, between race and education level, the p-value that we got is 0.256. We will not reject the null hypothesis because our p-value is bigger than the alpha. Race and education level occur independently of each other. Between race and income, the p-value that we got is 0.362. We will not reject the null hypothesis. We can say that race and income occur independently of each other. Next, between race and insurance status, the p-value that we got is 0.476, which is bigger than alpha. We will not reject our null hypothesis. Race and insurance status occur independently of each other. Next, between race and literacy, the p-value that we got is 0.002. This is smaller than the alpha. We will reject the null hypothesis. We can say that there is a relationship between race and literacy. They are dependent of each other. If a relationship do occur, we cannot ascertain if race affects the literacy or is it the other way around. We can consider race as non-modifiable because once you are born white, you will be white until you die. However, literacy is modifiable to some extent. You just need to study or go to academic institutions. So we can say that race will most likely affect the literacy. How about gender and education level? The p-value that we got is 0.52. Technically, this is bigger than alpha. We will not reject our null hypothesis. However, it depends on you. You can round off the p-value for it to become 0.05. If you do that, then it will become statistically significant and you have to reject the null hypothesis. In our video, we will follow the raw results of the software. So we will stick with 0.052. We will not reject the null hypothesis. How about civil status and income? The p-value that we got is 0.481. We will not reject the null hypothesis. We can say that civil status and income occur independently of each other. Next, between gender and insurance status. The p-value that we got is 0.874. We will not reject the null hypothesis. Next, between gender and literacy status. The p-value is 0.065. We will not reject the null hypothesis. Gender and literacy status occur independently of each other. Next, between education and income. This is what I have said earlier. You can have multiple categories in a variable and you still can use the chi-square. Here we have 5 categories in the variable education and then another 5 categories for the income level. The p-value that we got is 0.000, which is smaller than the alpha. We will reject the null hypothesis. We can say that income and education level are dependent of each other. Between income and insurance status, the most numerous is those who have zero income with no insurance, which is quite logical because you cannot buy an insurance without money. The p-value that we got is 0.196, which is bigger than alpha. We will not reject the null hypothesis. Income status and insurance status occur independently of each other. How about income and literacy? The p-value that we got is 0.093. This is bigger than alpha. We will not reject the null hypothesis. They occur independently of each other. Between insurance status and literacy, the p-value that we got is 1.000. Why did we have this result? Remember that chi-square is analyzing for the proportion of the two variables. 25 divided by 40, you will get 0.56. Then 44 divided by 71, you will also get 0.56. If you have the same proportion between the variable, you will get a p-value of 1.0. This is bigger than alpha. We will not reject the null hypothesis. Insurance status and literacy occur independently of each other. That is the end of our chi-square test. I hope you learned a lot in this video. Please like this video and subscribe to my channel. We will see each other next time to study statistics.